of 100 students, 73 likes coffee, 80 likes tea, and 52 likes lemonade. So let me draw the three circles represented on a Venn diagram, this particular data that we are looking at. And we are saying that, let's say, suppose this circle belongs to coffee, 73 individuals. This circle belongs to tea, which is 80 individuals. And this circle belongs to lemonade, which is 52 individuals. So 73, 80, and 52. It may be possible that some of these students do not like any of the three drinks, very clearly given to us. Then the difference between the maximum and minimum possible number of people who like all the three drinks. All the three drinks is what they're concerned with. Difference between the maximum value of that and the minimum value of that. Now, we also understand one equation that if I add 73, 80, and 52, if I add 73 plus 80 plus 52, the basics tells us that this is equals to at least one, the number of people under at least one category, plus the number of people under at least two categories, plus the number of people under at least three categories. This is what we mean. And we also know that at least one must be greater than equals to at least two, and at least two must be greater than or equals to at least three. This is what we know. Now we want to maximize the value of at least three. At least three is nothing but who like all the three drinks, right? So either we are maximizing this value or we are minimizing this value and then taking the difference of the two is what the question is talking about. So if I look at the sum on my left hand side, 8 plus 7 is 15, 200, 205 is my sum. So 205 should be at least 1 plus at least 2 plus at least 3, right? Now, in order to find out the minimum possible value of at least 3, minimum possible value, I need to maximize the value of at least 1 and maximize the value of at least 2, correct? Because the sum of these three values was a constant, which was 205. Now, total number of people in the class was how much? 100, right? What can be the maximum possible value of at least 1? Maximum possible value of at least 1 can be 100. All of these individuals, all of these students who have been surveyed for this particular thing ends up taking 1 out of the 3. Possible, right? It may be possible over here. What they are saying over here is it may be possible. It is not necessary. Clear? So I can take my value of at least 1 as 100. At least 1 will be greater than or equals to at least 2. So what can be the maximum possible value of at least 2? Maximum possible value of at least 2 will also be equals to 100. That gives me the minimum possible value of at least 3. This will become minimum, right? So this minimum possible value of at least 3, our minimum possible value will turn out to be equals to what? 5. Clear? Now do the reverse of this. You want to maximize this. That means you need to minimize this. But we also need to understand that if I look at this, what can be the maximum possible value of this? Can the maximum possible value be greater than 52? It cannot be greater than 52, because if this value over here turns out to be greater than 52, then what happens is that some of these values will become negative, which is not allowed because you are looking at the number of students. So what is the maximum possible value of at least 3? Maximum possible value of at least 3 will turn out to be equals to 52. We don't even have to solve that entire equation as well. So maximum value turns out to be 52, minimum value turns out to be 5. What is the difference between the two? 52 minus 5, that's turning out to be 47. Option D is the correct answer for this.